as we continue ways to display data, in section 10.1, we talked about collecting data. We talked about the best way to survey for an experiment and collect the data. And you'll recall that we looked at an experimentation and questions. Section 2, we started talking about the way we display it. And in section 2, we went over pictograms, dot plots, frequency tables, stem and leaf, back-to-back stem and leaf, which I asked you to look at the example I gave you so we didn't copy all that data down. Histograms, bar graphs, double bar graphs, and then we finished out with circle graphs or pie charts, okay? So if you've already printed out these examples or you have that PDF available, I'm going to continue with the last couple of ways of displaying data that we're going to go over. So we're going to take a look at three ways, a continuation, three more ways to display data. So in this video, we're going to take a look at line graphs, scatter plots, and trend lines. Okay? So displaying data. Actually, I'm going to write down the ones we already did. That way you have kind of a huge list to go through it all. So again, we started off with pictographs, and then last time we also talked about dot plots, or we also called those line plots, remember? Then we went on to a frequency table, which is a way to collect the data, how often something occurs. From there, we went to stem and leaf plots. And that could be a single stem and leaf, or it could be a back-to-back stem and leaf. So both of those. Then we talked about the difference between a bar graph and a histogram. Okay. Histograms are connected. They've got to be in order. I'll kind of sum that up at the end. Then we looked at bar graphs, both single and multiple bar graphs. And then we finished out last time with circle graphs. Or a lot of times people think of those as pie charts. So what do we have left? Well, the three that we have left that we're going to look at today in this section are line graphs, scatter plots, and then we'll finish out with trend lines, or sometimes you hear it as lines of best fit. Okay? So these all came from section 10.2. These three, so our lesson will not be as long, are in section 3. All right. So what I'm going to do first is I'm going to pause while we look at, I'll first talk about line graphs. Then I'm going to pause while I set up my frequency chart. Let me rephrase, I'm sorry. I'm going to pause then while I set up my information, my survey. But let's first talk about line graphs. Because when we talk about line graphs, okay, first of all, the name of it kind of lets you know we're going to have some lines or line segments. They show a trend over time. Line graphs are used when you're talking about time. How tall are you? as you grow up. So line graphs are used a lot in science. These tend to work at and show a trend of a variable over time. So if you think about, for example, somebody losing weight, they might say, okay, well, on Monday, I weighed in and I weighed whatever. And then next Monday, oh, look, I lost a pound. Oh, then you weigh in on the next Monday. Oh, I lost 2 pounds. You'll notice it's over time. So it's what's happening over time. So I'm going to pause this while I create the table of values that I gave you in this example that you'll find in your module. All right, so here's the first example that I've got with line graphs. And the table that's been given represents Manny's weight for the first 10 years of his life. So one of the first things I should have noted was, well, we're talking about 10 years. So this is age in years. Notice it only went to 9 because the first year, they're 1 month, 2 months, 3 months, up to 12 months, but that's still a year. So as an infant, weighed in, born at maybe 8 pounds. So here's our data points. Now line graphs represent time. So time always has to be on our x-axis or a horizontal axis. So since we're looking at 10 pieces of information, I would recommend if you have graph paper, use your graph paper. That'll be off the page. I'm going to try to give you kind of an idea here. I'm going to try to keep it somewhat consistent. This one's not bad. So I'm going to do this so that I can keep it looking pretty balanced. So I'll call this 1, 2, 3, 4 years, 5, 6, 7, 8. I may have just gone off the screen. I apologize. I think by then we'll get there. And I need to go from 0 pounds up to probably 90 pounds so that all the data is there. So I'm keeping the scale the same. And make sure I'm using the same ones. And so I'm going to then go 10, 20, 30, 40, 50, 60, 70, 80, 90. So what do these represent? We always must label. We always need to title and label your graphs. So as mentioned, down here we talked about this is Manny's age, 1, 2, 3, 4. So here's age measured in years versus months, for example. And then up the vertical axis is our weight. So we have our input and our output, our domain and our range. So here I'm going to say this is weight, and I need to tell me my unit of measurement. I'm using pounds. And I chose to go by 10-pound increments because I looked at the range and figured out that was the best way to represent the data. So we'll have to estimate a little bit. Okay, so then what we need to do for this line graph is plot all of these points. So 0, 8, I'm going to estimate that's about 8, 1, 20, 2, 3, 35, 4 comes all the way up to 50, 5 comes to 53, 6, and of course again this works better if you have graph paper, but I think you guys are estimating like I am. 8 goes to 80 pounds, and it should make sense for this growing child that the first 10 years of life They should be growing, so therefore they should be weighing more. And then this is how to do the line graph. The line graph, because it's a trend, over time, it's going to be made up of line segments. Okay? So what we'll do, and I'll start off with a ruler, and then I'm just going to kind of go freehand. What we do is we connect using line segments. So no, it's not going to be a continuous line because these slopes are changing. So you'll notice that it's changing. Some years you didn't gain very much. Other years it's a little more consistent. So we just connect them all piece by piece. And that's our line graph. And then of course there's one thing missing. We have to label and title the graph. So in this case, what are we representing? This is representing Manny's weight. So perhaps the title of this graph would be Manny's weight. So make sure, I'm going to always look for a title, and I'm going to look for labeled axes. I'm going to make sure you always have your units that we're comparing. There we go, there's a line graph. Okay. Now a scatter plot, scatter plots are pretty interesting because scatter plots look at the overall trend, an overall trend. Okay, so it's not an individual data point, it's a cluster of points. So let's take a look at a scatter plot. The name kind of implies that things are scattered everywhere. Scatter plots kind of just depends on the question you might ask, but there's not necessarily any sort of distinct line that you can come up with. So a scatter plot still shows a trend, not necessarily any distinct line, right? So this shows a general trend. And we have three different versions. We have a positive correlation, a negative correlation, or no correlation. So you'll notice I gave you three graphs. Okay. So we'll look at these three possible graphs. And on these three possible graphs, you only have three choices. Your data can either be heading in a positive direction, a positive trend, or what you'll hear more often in statistics is a positive correlation. We have a negative trend or a negative correlation. Or you have neutral, or you have no trend, no correlation at all. So let's look at what that could look like. Okay? Well, as we read graphs, we always read from left to right. We always read from small to large. We always read from 0 to the right. So if something is heading in a positive direction, that means I might have a whole bunch of data points, but if you stand back and look at them, it looks like as you read from left to right, these points are going up. So that's what we mean by a positive correlation. Similarly, a negative correlation would imply that as we're reading from left to right, it's having a negative effect, so it's going down. So perhaps we start with larger values, but then over time or as we keep going, it's going down. All right? And then sometimes we might not have any correlation at all. Which just means you end up with just this random, you can't really tell what's happening, it's just a cluster. Okay. So age is usually one that you'll talk about. You might do, again, there's a positive correlation between the height of a child between 0 and call it 20 years of age or 15 years of age. They're probably getting taller as they're getting older. And then of course they flatten out and then they start shrinking a little bit with age. Negative correlation. All right, maybe as somebody goes, let's go from 10 to 50 years old. How often do you get grounded? Well, maybe you got in trouble more often, I hope, as a child than you do as an adult, because you've learned your lessons. No correlation. Does age affect ice cream flavor preference? Well, no. So there's just no correlation. Okay? It could be everywhere. So that's kind of some examples there. All right? And then the last one we're going to take a look at is trend lines or lines of best fit. So we are going to have to come up with the equation of a line. So this is refreshing from chapter, I think, 8 in the book, the end of the last course, if you took 2120, is where we ended that class. So I will refresh your memory on finding the equation of a line. So let me pause. I'm going to set up that data again for the example that I have posted for you. Okay? All right, here is the next example, the example of trend lines. And basically you have taken your survey and here are your results. So the first thing we want to do is create a scatter plot, just like we did before. And I didn't fill all these in because they were going to start getting crowded. I started counting by 5s. So here's the first 5, 10, 15, 20, if it's off the screen. So let's first graph our data points. All right, we're going to create this scatter plot in order to create the trend line. So I need the point 1, 6, 4, 5. So you do this, I'll do this, and we'll meet up here in just a minute. Okay. And then I need to label my axes. In this case, I don't have what this data represents, so I can simply label this as your x-axis and your y-axis because that's what our data points are. And now what we want to do is we want to find the line that fits the best. So easiest thing to do, grab a ruler, grab a piece of paper, grab a straight edge, grab something, and the idea is you want to, this isn't as firm. I have a ruler, but it's a 3-sided ruler. But I want to find, if I put this ruler down, I want to find the best way to represent that. I'm actually going to try to grab, let me see if I'm looking around trying to see if I have a ruler or something else I can use right here that's a little more stiff. So hang on just a second. Okay. I just went and I grabbed a notebook pad, all right? But it gives me a nice, crisp, clear line, as you can see. So what I want to do is, I want to put this down, and I'm going to make these a little larger for you to see. I want to try to position this so that when I position this line, like let's say I position it right here, I want to have, going through as many points as possible, a line which best depicts all of these data points. So I want to pick 2 points that make it look like this line or ruler has half the data points below it and half the data points above it. Okay, so the easiest way is to just grab a straight edge and look on each side to see where you should slide it to represent the best fit. Okay? So I chose for mine, when I held this up here, for me it looks like it works really well between 1/6 and 14/1. Now it doesn't always be, it's not always the first and the last. It's just for my graph, those two look like they're probably going to be the best. Yours might be different. So there's a good chance that your answer may not match the back of the book or my answer, but that's okay as long as it represents your data. So if you don't use graph paper, if you use a fat pen instead of a skinny pencil point, it could look a little bit off. All right. So then what we need to do is we need to find the equation of the line. Now, to find the equation of a line, we need two things. We need a single point. Well, I chose 2 points. I chose 1/6 and I chose 14/1. So I only need 1 point for the equation of the line. So I'm going to choose, for mine, I'm going to choose 1/6. You can choose 14/1, you'll get the exact same equation. The other thing you need is the slope of the line. And to refresh your memory, to find the slope, you need 2 points. And you need the difference of the y's divided by the difference of the x's. You need the rise over the run. You need the change in y over the change in x. Delta y over delta x. So if I use my first point as 1/6 and my second point as 14/1, again, it won't matter because we're talking about those 2 points. And what's my goal? My goal is to try to find the equation of this line because it looks like this line is perhaps the line of best fit for my data. It looks like it pretty much divides all the data points equally. All right, so if I keep going and I substitute in, this will give me the y value from the second point. The y value from the first point is a 6. The x value from the second point is 14. The x value from the first point is 1. Gives me -5/13. So it looks like the slope is -5/13. Rise over run. It looks like if I drop 5, if I go down 5, I'm going to go to the right 13. Now I'm going to use what's called point-slope form. Point-slope form says y minus the y from the 1 point that we chose equals our slope times x minus the x value from the 1 point that we chose. Now remember, I chose the point 1/6. We found the slope to be 5/13. So I'm going to use those and simply substitute them in. Y minus the y from the 1 point that I chose. Our slope, -5/13. X minus the x value from the 1 point that we chose. And you're done. That's the equation of the line. You're done. You're done. Now, if you're used to seeing, but my teacher says it has to be y equals mx plus b. Y equals mx plus b. All right, we'll do that. We'll do that. I'll take that equation for you, because here it is. I'm going to erase this now, and I'll have something I want to write here in just a second. I'll tell you in just a second. Let's say you're so used to equations of lines having to be y equals mx plus b. Well, then let's solve this equation for y. Let's just solve it for y. Okay? Or, now wait, where did I leave off? I left off with y minus 6. Okay, this is where I just left off. Solve for y. Okay, distribute your 5 over 13. Negative times a negative makes that a positive. Now remember, you're telling me you want y equals mx plus b. That's what you want. It doesn't matter to me. I'm finished over here. I have my line. I'm done. But in case you wanted to keep going, combine like terms. So I'm going to bring the 6 to the right. So I now have mx. I'm going to bring the 6 over here. So I now have 6 added to the 5/13. Well, in order to add this, or you could have said 6 and 5/13, I need to have a common denominator. So I need to multiply the 6 by 13 over 13. Okay? Negative 5 over 13x. 13 times 6, let's see, that's 10 times 6 plus 3 times 6. 10 times 6 is 60, 3 times 6 is 18. So that gives me 78 over 13 plus 5 over 13. Our final equation, if you're more comfortable having it as mx plus b, would be 5/13 x negative plus 83 over 13. But again, as a mathematician, we only need a point and the slope. Once I have point-slope form, I'm done. You can leave it this way. That tells me my starting point is the 0.16, and from there I can rise and run, negative 5 and positive 13. Or, if you want, here's your y equals mx plus b. I will take it either way. Okay. And then the last example I put on that paper is a multiple line graph. So again, I'm going to pause while I set up the data, and then we'll go from there. All right, now I did paraphrase the last example a little bit. It actually says the Mountain View Middle School and the Lakeside Middle School collect all the aluminum cans for recycling at the end of each year. The data shows the weight in cans. So these represent the weight in cans. And of course, I have to tell you if it's a metric or English measure, and this one is in pounds. Recycled from the year 2008 to 2013. Make an appropriate scale and draw a double line graph. Make sure to create a title for the graph, label the axes, and create a legend to explain the data. All right, so, well, going up the x-axis, we usually do the year because we're talking about time. So since we have 1, 2, 3, 4, 5, 6 data points, I'm going to try to space these out. Again, if you have graph paper, that works wonderfully. So 1, 2, 3, 4, 5, 6. I guess I could have spaced them farther, but that's okay. And then these represent the year. So, I could go 2008, 09, 10, 11, 12, 13. I probably should have spaced them out a little bit more, but I think you all will get the idea. And then notice our range. Our lowest number in here is 400. It looks like our largest number is 900. So I think I'm going to count by 100 pound intervals. So I'll call this 100, 200, 300, 400, 500, 600, 700, 800, 900. Am I on the page? Oh, barely. Okay. So our labeled y-axis is weight in pounds. And these are by hundreds. 100. I'm going to start up here so I don't blur. And then we have two different schools that we are comparing. We have Mountain View and we have Lake View. So we need to make a legend. We need to have something, whether it's two different colors, whether it's a pen and a pencil, whether it's a dotted line and a solid line. Sometimes you might see a legend where one line is solid, the other line is dotted, or somebody else makes a line up that has made up of like a bunch of plus signs. Something to distinguish each line, okay? If you've got students who are colorblind, you'll want to use a distinct dark marker, so you need to make the texture of the line different. If they're not colorblind or you can see the colors okay, I'm going to choose two different colors, all right? I'm going to let green represent Mountain View. So I need to make my legend. Mountain View, I'm going to use green. And for Lake View, I'm going to use blue. And again, you can use textures if you prefer. Okay, so I'm going to graph my Mountain View data points. Mountain View for the year 2008, they collected 700 pounds of recycling cans. 2009, 600, 2010, back to 700, 11 was 800, 2012, wow, 900, 2013 dropped back down to 800. And then again, since this is a line graph, we just connect each of these line segments from left to right. I'm going to freehand it now just to speed up the process. Okay, so there's our data, our line for Mountain View. I'm going to go back and do the same thing for Lake View. 2008, 500, then we went 400, 600, and if they run into each other, that's fine. If they cross over each other and intersect, that's absolutely fine. We just follow the data points. And again, using a ruler, I'm going to speed up the process with our example. We just connect these line segments, and so you can see in any particular year how it's going and you can compare. And so that's a double line graph. You can have multiple lines on the same graph. All right, guys? So that ends the way to display our data. And some of the toughest ones are trying to figure out which way you want to display the data. So choose wisely. Kind of going back. Remember, bar graphs were used to compare data items when the categories were grouped. A histogram is used to compare data grouped in numerical order. So we use a histogram when order matters. Okay? Bar graphs, the order didn't necessarily matter. We may have been comparing people. Stem and leaf showed individual data points that were grouped into intervals. So the stem and leaf, remember we clustered them like everything in the tens column. For the first, our stem, I think we had ages in an art class or something. So stem and leaf always group them in intervals. And then our line graphs are used as trends over time. Okay? Those data changing over time. And then the other type of graph we talked about was a pie graph or a circle graph. And a circle graph always compares a part to a whole. So a circle graph or a pie graph, you always have the entire data set, the entire class, or the entire room that you're surveying, and it's broken into wedges or sectors. Right? So those are the different ones. So depending on what your experiment involves, depends on how you want to display your data. Right? So until next time, have a great afternoon or evening.